Hello friends, I welcome you all for the session of belt drive part 7. So the objective of this video is to solve the numerical on V-belt drive as we have discussed the design procedure in previous video. First numerical is, it is required to design a V-belt drive to connect a 7.5 kilowatt 1440 rpm induction motor to a fan running approximately at 480 rpm for a service of 24 hours per day. Space is available for a center distance of about 1 meter. So what is given? Given data is initially power is given, that is 7.5 1440 rpm induction motor. So this is nothing but input speed. So we will call it as N1. Then running, we have to connect it to a fan which is running at approximately 480 rpm. So that is N2. So this is driving pulley and this is driven pulley. Service hours is 24 hours per day. So operational hours per day is 24. Space is available. So center distance is 1 meter. So as per the video number 6, we have seen the design procedure. In that, first step is to determine correction factor, which is given by FA. Now this correction factor, it depends on type of driving machine, type of driving unit and operational hours per day. So now which type of machine we are, what is your driving unit? Driving unit is induction motor. Here it is induction motor, induction AC motor. Operational hour is 24. Now actually induction motor is in this column, so we have to refer this 3 and operational hour is 24. So we have to refer this column. At the same time, driving machine is, your driving machine is fans up to 7.5 kilowatt. So this light duty means what? Up to 7.5 kilowatt. So this and this column. So intersection is 1 at 1.3. So FA is equals to 1.3. Next, you have to find out design power, and how design power is given? FA into transmitted power. So what is FA? 1.3, and transmitted power means input power, that is 7.5. So you will get 9.75 kilowatt. Now next is to decide the type of cross section of the belt. As I have told you, there are 6 types of cross section: Z, A, B, C, D and E. Z is for low duty application and normally used as A, B, C, D, E. So it depends on speed of faster shaft, that is 1440 rpm. So here is the chart, that is design power, speed of faster shaft versus design power. So design power is 9.75, this one 9.75. So you can say this is for 10 and this is for 5, 6, 7, 8 and 9, 9.75. So somewhere over here. So if suppose I am drawing a vertical line in this section, and then 1440 rpm. So 1440 rpm. So this is one for 1500 and this will be a 1440 rpm. So the point of intersection in the region of B. So if suppose you are getting point of intersection in this region, it means your cross section is A. Now here the cross section is B. Similarly C, D, E. So what type of cross section we are getting? That is B. Next is determine diameter. Once you have got cross section, you have to go for diameter. Which diameter? Small diameter and capital diameter. Now how to find small diameter? So as we are knowing the cross sections, based on cross sections we can find out the diameter. In previous video I have told you that while selecting the smaller diameter of pulley, we have to go with recommended value. Here are the 2 values: permissible minimum pitch diameter and recommended minimum pitch diameter. So recommended one we have to refer. So cross section is B. So which value? 200. So 200 is your correct value. So small d is 200 mm. So how to find capital D? We are having formula. Capital D is equals to small d into input speed upon output speed. Input speed means 1440 and output is 480. So from this, yeah, on solving this ratio is nothing but equals to 3. That is nothing but speed ratio again. 3 and 3 into 200 is 600 mm. So this is how we have found the small d and capital D. So now next step is to check whether this diameter are in the table of preferred pitch diameter of pulley. So it depends on cross section. So our cross section is B. So we have to check our values in this. So here we are having small d value, that is 200, and we are having capital D value 600 over here. So as your values of small d and capital D are in the table, so directly take that standard values. But if suppose they are not in the table, then you have to go for the nearest value. It means if your value is 189, then you will go for 190. If it is 141, then you will go for 140. Is it okay? So our 200 and 600 is lying in the table, so that will be our final values. Now next, once you have found diameter, we have to find out the pitch length of belt. How to find pitch length? So we are having the formula for open belt drive. So that is this formula. In this we are needing C, capital D and small d. So we have found these two values, and C we are having as 1 meter. So that is nothing but 1000 mm. So we are substituting it and we are solving, and we are getting this 3296.64 mm. So once you have got this, the next step is to select preferred length of belt. Similarly as like belt, we have belt diameter. We have found D, and then we have checked for standard values. Same we are doing. We are finding L, and we are checking for the standard values. Based again, it depends on cross section. So our cross section is B. Now check for this value 3296. So coming in downward section 3200 and 3600. So our value is in between these two. So which value you will go for? You will go for nearest value. So 3296 is nearer to 3200. So you will select L as 3200 mm. So now when you are substituting C as 1000, you are getting L as 3296. But now when you are substituting L as 3200, we have to check what will be our C. So next step is to find out correct center distance. So again same formula, substitute capital D, small d and L and find out C. So you will get this equation in a quadratic form, C square minus 971.68 C plus 20,000 equals to 0. So on solving this, you will get the center distance as 950.64 mm. 950.64 mm. Okay, so this is your corrected center distance. Next is belt pitch length. Now how to find belt pitch length? We have found belt pitch length. We have to find correction factor FC, which depends on belt pitch length. What is our belt pitch length which we have found? That is 3200. 3200. So cross section is B, 3200, and FC is nothing but the corresponding value. So where it is 3200, this is 3200. Draw a horizontal line, and that corresponding value will give you FC. So it depends on cross section and pitch length. So it is 1.08. FC is 1.08. Next step is to find out correction factor for arc of contact. So before that we have to find out arc of contact. So ninth step is angle of wrap and FD. So angle of wrap is given by this formula. So we are having the three values, capital D, small d and C. Substitute it and you will get 155.71. You can round it up to 156. Okay, now you have to find out FD, corresponding FD. So 156 is in between these two. 157 and 154, but it is nearer to 157. So directly you can take 0.94 as your FD, or you can go for interpolation also. But in this case, that interpolation value will be very negligible again. A difference between these two values will be very negligible. So we can directly take it as 0.94. Now next step is to find out power rating. It depends upon the cross section of faster shaft, pitch diameter of pulley and speed ratio. Now as I have told you that now cross section is B. Now for power rating we have to use this table actually. There are 5 to 6 tables. From V.V. Bhandari I have taken this table. So you can refer for other cross section, that is Z, A, B, C, D, E. So for that the tables are 13.16 to 13.20. Now this table is for B section and V belt. Now it depends on speed of faster shaft. Now the speed of our faster shaft is 1440. N1 is 1440. Diameter of smaller pulley is 200 mm. So you have to use this column and this row. So this 5.90 is the intersection value. So this will be your power rating. But at the same time you have to consider this additional power increment per belt for the speed ratio of. Now our speed ratio is 3. So you have to check for the value of 3 over here. So actually now this value here in this table, the values are from 1 to 2. So we are not having value for 3. For 3 actually we have to refer this last column. Why? Because here it is given 2 and over. So 3 is more than 2. So refer this column. And again extend your horizontal line, and this value 0.46 is your point of intersection. So what you have to do is you have to add 5.9 plus 0.46, and this will be nothing but your power rating for cross section B. Here I have written PR is 5.9 and plus 0.46, and the value is 6.36. Number of belts. Last, which you have to find out. Number of belt is given by P into FA, and this is actually, make it correct, P suffix R into F suffix C into F suffix D. This all the values we have found. Power is given 7.5, PR we have calculated as 6.36, FC is 1.08 from table, and FD is 0.94 from table. So you are getting 1.51, and that is nothing but belt is not in point. So directly 2 belts are selected for such type of application. Okay. Now we'll go for our next numerical. I hope you have understood your first numerical. If you are having any doubts, you can write in comment box. Kindly please like, share and subscribe the video. Now next numerical is the following data is given for the open type V-belt drive. Diameter of driving pulley, it means small d is given. Diameter of driven pulley, capital D. Groove angle for sheaves. Now here sheaves is nothing but it is for pulley. Actually you can imagine that if your angle is 40 degree, it means it is the angle of groove angle for belt. Groove angle for belt is always 40 degree, not groove angle actually. Wedge angle or V shape. For V shape belt it is always 40 degree, and for a pulley it is 34 to 38 degree. And now in this numerical it is given 34 degree. Mass of belt is 0.5 kg per meter. Maximum permissible tension in belt. How much tension a belt can sustain? That is 500 Newton. And then coefficient of friction, it is denoted by capital F. Sorry, small f. And angle, contact angle for smaller pulley, that is alpha S. Speed of smaller pulley, that is N1. And power to be transmitted, that is 10 kilowatt. So they are asking how many V belts should be used, assuming each belt takes its proportional part of the load. So we'll see how to solve it. So next is, this is the given data which I have already told you in previous slide. So angle is given by this angle for groove angle for shapes, it is given by theta. M is given allowable tension, F alpha is N1 and K. So we have to calculate number of belts. Now the number of belt formula in previous numerical was different. It depends on different parameters. That was a selection procedure. But now as here allowable tension is given, the number of belts, it depends on allowable tension and maximum tension. So the formula is number of belt is equals to maximum tension in belt upon allowable belt load. So maximum tension, as we know that there are two types of belt. If suppose now this is bigger pulley and this is smaller pulley. So this is how the belt is wound. Okay. So this one is slack side and this one is tight side. Slack side is given by P2. It is given by P2 and tight side is given by P1. So maximum tension in belt. Maximum tension is in case of tight side. So that is nothing but P1. So we have to find out P1. And allowable belt load, it is directly given as 500 Newton. 500 Newton. So now we are having the formula P1 minus mv square upon P2 minus mv square equals to e raised to f alpha upon sin theta by 2. This is nothing but the belt tension in case of V belt drive. Whereas in case of flat belt drive, simply left side is same, and in right side there is e raised to f alpha. Okay. So now first you will find out alpha. We are not knowing alpha. Now in this actually what we are knowing m, we are not knowing v, and we are not knowing alpha. So first we will solve this term. So first we will find out alpha. Alpha, it is given directly. Sorry, it is given 157. Simply we have to convert it into radians. This is in radians. RAD. This is in radians. Okay. So for radian we have to multiply it by pi by 180. Then this term 30 is nothing, theta is nothing but 34. Alpha you are having in radian, and f is coefficient of friction which is given 0.2. So from this term is 6.52. Now here v is unknown. So find out v. Pi dn upon 60 into 10 raised to 3. So 60 into 1000, and this value. N is input speed and d is also input driving pulley diameter. So you are getting this as v. Now here you can calculate mv square. So mv square is 113.70. So again now substitute this mv square and this value. So this how. Now we can simplify it in terms of equation. P1 minus 6.52 P2 plus 6 to 7.61. On solving you will get this equation. So we will call it as equation number 1. Why we are saying now, actually there are two unknowns, P1 and P2. We need to find out P1 and P2. So two unknowns and one equation is not feasible. So there should be two unknown and two equations. So we have to go with second equation. What will be a second equation? So now you can go back. You have used small d, capital D, theta, m, allowable belt tension, f, alpha s, n1. What you have not used? You have not used yet power. So there might be some relation between power and P1, P2. So we are having a formula, that is power is equals to, power in kilowatt is equals to P1 minus P2 into V upon 1000. So P1, P2 unknown, power is known and V is known. So substitute the values. 10 equals to P1 minus P2 into V. What is V? 15.08. 15.08 upon 1000. So on solving this equation, you will get the simplified equation. We will call it as equation number 2. P1 minus P2 minus 663.13 equals to 0. So On solving equation number 1 and equation number 2 in your scientific calc, you can find out P1 and P2. So it is 896.96 and P2 is 233.83. So number of belt is P1 896.96 upon. Why? Because our formula is maximum tension in belt upon allowable tension. So maximum tension is 896 and allowable is 500. So you can imagine this value is more than 500. So we cannot go for one belt. So number of belt will be more. So that is one answer is 1.794. So that is 2 belts. So number of belts will be 2 belts. Is it okay? If you are having any doubts, please mention in comment box. I will solve your doubt. Thank you for this watching video. Please like, share and subscribe among your friends. Thank you.